And we are back with .NET Conf Focus on Blazor. We had to call in our next speaker, Javier Calvarro Nelson, who is speaking all the way from Spain about JavaScript two-way interop. Javier, how's it going today?
Hello, good, thank you. How are you? I'm glad to be here.
Good. Do you have to deal with snow like we're doing here in Seattle?
No, not really. It's all sunny here.
Perfect. You know, that's what we want to hear. So, what do you got in store for us today?
So I'm going to be showing you how to do JS interop and how to be successful doing it, like how to solve the most common problems that people run into.
Excellent. Take it away, sir.
Perfect. Hello, everyone. I'm Javier Calvarro. I'm a senior software engineer in Microsoft. I work on the SP.NET core team, mostly focusing on SP.NET and Blazor. Today, I'm going to talk to you about JavaScript and .NET Interop in Blazor applications. Normally, when we build Blazor applications, oh, yeah. Yes. Start sharing. The Skype is new for me. Okay. So can you see my screen? Is that the close button? Okay, perfect. Let me start the presentation. Yep. So as I said, I'm going to talk to you about JavaScript and .NET Interop in Blazor applications. Normally, this is not something that we need to do very often. When we work with Blazor, we like to be on the .NET side of things where like we are happy and productive. But there are some cases in which we need to interop with the browser in order to leverage some specific API or to integrate with some third-party library that is not yet available in .NET. In many cases, the community has already gone and built a package that is ready for us to use so that we don't actually have to create the functionality ourselves. But in some other cases, there's nothing else we can do but to write some JS interop. So my goal here in this talk is to show you how to interop with code running on the browser and how to solve most of the common problems when doing JS interop. I'm hoping that at the end of this talk, you get a good grasp on how to use JavaScript interop and you can be successful at it. So with that in mind, I'm going to start my first demo. This is a very demo-heavy presentation. And what I'm going to try to do is we're going to try to build an app that says hello from where you are from. For example, in my case, I'm in Spain. So I have already a solution here where I have created some things so that we can go a bit faster. I have this Blazor geolocation file, which is where we are going to be putting our JavaScript code. I have this city greeter component, which is going to display hello from my city, and it's going to use JS interop and the geolocation APIs to get your coordinates, and based on that, get the city you are like visiting the page from. And then I have a location mapping service that I'm gonna use to map the city to the specific coordinates. So the first thing we're gonna do is we're gonna go to this city greeter component, and we start by simply displaying hello from my city. And we don't have a city yet, so we're gonna create a property to hold that. And now we're ready to start using JS interop to actually get the location coordinates and to translate that into a city. In order to do that, we're gonna override the uninitialize method, and I'm gonna just paste the code here. And we are going to inject the IJS runtime service which is the service that we use to interop with JavaScript. So we're also going to need the location mapping service, which is, as I said, a service that I created to map the coordinates to a city. And with that, unless I've typed anything wrong, which I haven't, then we should be golden. So if I run my app now, and Visual Studio is taking some time, we are going to see that it shows, it asks us for the location. It's launching. Okay, so it says hello from somewhere. So we did something wrong. Yeah, so obviously this is not going to work because we don't have our get location function defined. So the next thing we need to do is to actually define that function. And we do that in this blazor.geolocation service. I've already registered this file into the host file so that it gets loaded when it loads the app. And now if we reload, hopefully the demo will work. Yeah, there you are. So it says hello from Madrid and the location coordinates. So now I'm closing the app, and I've actually really cheated a bit because I'm not pre-rendering the app. So the next thing we're going to do is we're going to pre-render the app and see what happens. So if we pre-render the app and run again, we see a failure. And this is because we're trying to use JS Interop during pre-rendering, which is not something that we can do because there is no JavaScript runtime available at that time. So the best way to do pre-rendering, if you are able to, is to, instead of overriding on initialize async, do it inside on after render async. So there are a couple of things that we need to do different if we do on after render async. First, we need to check this is first render, because on after render async will run every time the component renders. And then we need to explicitly call state has changed to tell Blazor that something has changed since the UI needs to be re-rendered. If we didn't do this, we would end up with an infinite loop of rendering, which is not something that we want. So now we can rerun the app. And there we go. Hello from Madrid again. Now, this is how we do JS Interop from .NET to JavaScript. The most important thing is that the function that you create needs to be available in the global scope, so in the window, essentially. And what we're going to do next is we're going to do it the other way around. We're going to call .NET code from JavaScript code. In order to do that, what we're going to do is we are going to simulate a location change and an event that JavaScript is going to trigger that we call a .NET method to update the location. For that, we're going to create a button here that simulates the location change. And then we're going to add a couple of methods to handle the location update. So this update location method will take new coordinates, and we'll find the new city and we'll update the location. And then this is the handler for the button. Then we're gonna change our location. We're gonna change our JavaScript interop code to use a location service that we're gonna inject in a few seconds. And that is gonna take care of doing all the JS interop for us. It's a good pattern to encapsulate all your JS interop code in a class, and that way you only have to look for it in one place. So let's inject this. Well, we have to create the geolocation service, so let's do that. First, I have the geolocation service ready here. I'm gonna copy it, paste it, and I'm gonna give you an idea. I'm gonna give you a rundown of what it does. So it injects the JS runtime. It defines an event position change. As you can see, we're using statics. This is not the recommended way to do this. I just want to show it to you for simplicity. But there are better ways that we're gonna see later on that you can use to do this. Then we have this location change static method, which is the method that JavaScript is going to call. If you can see, there is this JS invocable method that tells us that this is a method that is accessible from JavaScript. And then here is the old get coordinates method that we saw a few seconds ago that simply wraps the original method that we had in the component. So with that, we simply need to bring in the geolocation service. And one last step is to register it in startup. So I have it here. Now, if I run the application again, we're going to see the same thing. We're going to see the button up. We're going to see hello from Madrid. And when we hit this change location, nothing is going to work because we forgot to do the JavaScript side of things. So we need to actually implement those two functions. And we're just going to add them here. And there are two simple functions. One is notify location changes that will use this .NET object that is available for you when you're using Blazor. And invoke async will do the call to the .NET API. And the arguments for it are the assembly name and the method name, and then any parameters that you want to pass. In this case, the name needs to be unique across assemblies, within your assembly, sorry. And then the simulate location change simply grabs a bunch of random latitude and longitudes and then notifies of the changes. Now, if we run the app, we'll see that it actually changes from Madrid to Barcelona. So that's it for my first demo. I'm gonna go back to the slides for a second. Let me see if I do this correctly. Yes. Then the main points we can take from here is it's very easy to use JS Interop to call JavaScript from .NET. The best place to do it, if possible, is to do it inside on after render async, and that's because that's where we know JavaScript Interop is going to be available, especially if we want to support pre-rendering. And then we can call static methods from JavaScript, but there are better ways to do it. Finally, while I wrote my own library here, there are many libraries in the community or libraries that the community has built to do this. So you don't have to be writing your own. This is for the case where nothing else is there. So with that, I'm going to move on to my next demo. My next demo is about how to upload files into your application. So there are many cases in which we need to use JS Interop to do something like this, and there is no obvious way. If you, for example, need to upload a 10 megabyte file, how do you do it? So in the next demo, we're going to build a small application that handles the upload of pictures and shows them in the main page. To do that, what we're going to do is we're going to use JS Interop to grab the contents from a file input, break it into 8 kilobyte chunks, and base64 encode them, and send them all the way to the server where they will be collected. And once all the chunks are collected, we will be able to take some action on it. So with that, I'm going to go back to Visual Studio. So I already have a solution set up in a similar way. I have a JS file where I'm going to put all my JS Interop code. I have an input file component that is going to handle the file uploading process I have a file uploader class that is gonna implement all the small details about doing JS Interop with the client. And then I have an upload page that is gonna offer me the chance to upload the page, upload the image, and display a result. So with that, let's go and start creating this thing. Let's go to the upload page first. And what we're gonna do is we're gonna create a label, and we're gonna define an input file component that is gonna take in a name for the name of the underlying input, and it's gonna define an event on file uploaded that will fire once the upload is complete and the file can be consumed. We're gonna put that in upload. We're gonna inject a repository to handle the saving the file, and then we're gonna have a bit of code to handle the UI. That's our UI code. If there is no result, we don't display anything. If the file was uploaded successfully, we will display success. Otherwise, we will display failure. Finally, we need to add the code to implement the actual logic. So we define the field for the result, and we define the save file method that simply calls the repository to save it. If everything goes well, it says success. If something goes wrong, it says failure. Now, the next thing we want to do is we want to look at implementing the input file. So to implement the input file, we're going to start by creating an input field. And we're going to hold a reference to the field that we'll add in a few seconds. We're going to mark it as input type field, and we're going to take in two parameters, the name and the. We're going to take two parameters, the name, and then we're also going to subscribe to the onChange event, which is what is going to trigger the upload. So we are going to be implementing iDisposable, and we are going to inject the JS runtime. The next thing is to define the parameters that we describe in the page. So the parameters are here. Let me close this. Now we need to define a couple of fields. The first field is a file uploader, which is a class that we'll create in a few minutes that will handle all the low-level details of doing the JS interop, handling of the chunks, and like firing an event once everything is done. Then we are going to override on after render async, and on the first time we're going to initialize this file uploader. We're going to subscribe to the upload completed event, and then we are going to initialize the component. So I'm gonna very quickly copy the rest of the code here. So these are just helpers. So on upload completed, we'll simply fire the event callback that our input component has. The start upload will check if we can receive a file at this moment, and we'll instruct the JS side that it can start sending the file. And then we want to implement this post because we're going to be handling server resources like memory and things like that. And we want to get rid of those resources if the user cancels the upload or moves to a separate page or something like that. So it's a good idea to implement iDisposable and make sure we free up all the resources that we create. So now we're going to go into implementing the file uploader. So I'm going to go here to this file uploader. I'm going to paste a bunch of code they already wrote. And we're going to skip through the fields for a second. We're going to focus on the methods. First of all, we inject we receive the JS runtime, which we need to do JS interop. Then in the next line, we use this .NET object reference.create and pass a pointer to ourselves, which essentially what this does is it creates an object that we can pass to the JavaScript side, and that makes the object visible to the JavaScript side. So this way, the object can invoke .NET JS invocable instance method on this object. Then we define an event for when the upload has been completed, and we implement the methods that we define or that we were using in the input file component. So we have this initialize async, which takes care of initializing the underlying JavaScript, and it passes down the upload field, which is an element reference to the element on the page, to the HTML element on the page that we're using. And it passes a reference to, it passes the .NET object reference to this file uploader so that the JavaScript side of things can upload the file. Then this method simply returns an uploader reference, which is a way to keep track of an object in the JavaScript side of things. This is just a number that we created. Then we have this can_receive method that is just a helper to know when we are able to receive a JS interop, when we are able to receive a new file. And finally, we have this begin receive file or begin receiving file that notifies the JavaScript side of things that we're ready to receive a file. And it passes the uploader reference. Then that returns file details. So file details is a very simple object, which is just a name and a number of segments. So if we have, for example, a 16K, 18K file, it's going to be an 8K segment, an 8K segment, and a 2K segment. Then the main method for receiving the data is this receive segment. And what we're doing in this receive segment is using some of the new memory low-level APIs to get a shared buffer of a given size. We are sending all the data base64 encoded. So we base64 decoded. Then we add it to the list of segments that we're keeping track of. And once all the segments are collected, we create a new stream, which is it's this chunk stream class. I've created it myself. It simply exposes all the individual regions of memory as a uniform stream, and then it fires the upload completed event with this file descriptor, and it can be consumed. And then we implement this post so that in case something happens, like someone navigates to another page or something like that, we can free all these precious memory resources. So that's it for the file uploader. Now we need to implement the JavaScript side of things. And to do that, we are going to go to blazor.fileupload. And we're going to start by creating an initialize method. So this initialize method gets called by the file uploader, and it will receive the field that it needs to watch and the reference to the uploader. So this is the .NET object reference that we passed before, and this is the HTML element reference that is an element that we pass when we initialize the field. We simply create an identifier for this, and we store all of them in a map. So you can imagine if you were to have multiple file upload, multiple input file components, you would do something like this. You simply store them in a map or in an array or something like that, and return an identifier to the server so that it can uniquely identify each one of the elements. Then we need to implement the only function that the server ever calls on the JavaScript side, which is begin sending file. And this begin sending file receives the identifier and simply searches for the uploader. That's why we use the uploader reference. And once it finds it, it calls begin send file. So on the JavaScript side, we have this file uploader class, which I have here. And this file uploader class, again, receives the field, receives the uploader. It sets everything up as fields. Then what it does when it receives a call to begin send file, it uses the field to find the list of files, and then finds the file name and the number of segments, and then uses set timeout to start the file upload after it has returned. So this is a small trick that we use because we cannot start uploading the file right away. We tell the browser, run this code immediately when you're free. Essentially, this is what this means. And this send file is the method that takes care of uploading the file. Then we return the name, we return the number of segments so that the file uploader is happy on the server side. And then in our send file method, we simply keep an index of the bytes that we have sent to the server. And while the number of bytes is less than the file size, we create a base64 encoded chunk, and we use this file uploader here to call the receive segment method on the base64 with the base64 chunk. Then I have a bunch of like helper methods here that simply handle like figuring sizes and base64 encoding and all that. So if we go back to our file uploader, we'll see that this receive segment receives the base64 encoded, decodes it, and when everything is done, it fires the event. So we should be ready to save everything and run the application. And the first thing we're going to see when we run the application is we're going to see an image with the Blazor logo. And then we're going to try and upload our own image. Okay, so here's our Blazor logo. If we hit the upload button, we see our component. We can choose a file. I'm going to choose my picture. And it says the file was uploaded correctly. If we go to the home, we can see the image. So that's how you do large file uploads in using JS Interop. So I'm going to go back to my slides for a second. So the main things we need to take away from here is that we can write components that use JS Interop to leverage browser-specific APIs. In this case, for example, the file APIs to grab the file contents. We can use .NET Object Reference to hold on to state on the .NET side of things. And that's important because we don't want to have any solution that relies on statics, and that might cause server-side Blazor to share status state between different users, which is not something that we want. Then finally, as a reminder, we should take care of disposing resources when we use JS Interop, and we need to handle this carefully because if we fail to do this, we can get into a pretty serious memory leak. So that's all for doing something of a more complex JS Interop. For my last demo, I want to show you something a bit more real, which is SPA authentication. So what I did is I grabbed the support that we have for authentication on SPAS for the React Angular template. And then I went ahead and implemented it myself for Blazor and using JS Interop. So that's what I'm going to show you next. So in this demo, there's not going to be live coding. I'm going to give you an idea of how I implemented this. I started from the base React template that has an authorized service and a login and a logout component and a login menu. I converted these components to be equivalent in the Blazor side of things, and I put everything into a Razor class library that I call Microsoft SPNet Core API Authorization Blazor. So this has this authentication based component that essentially handles login and logout on the same component. So I combine those two. Then this authorized service is here in this authentication service. And I essentially took the JS code from the React template, added a couple of helper methods to make my life easier, and I was good to go. Then I wrap all the calls to the JS Interop layer into this API authorization authentication service. As you can see, I'm great at names. And all the JS Interop is handled inside here. Then on the app side, I simply have a reference to the project, and then I declare my own authentication controller to handle the authentication. So I also have a redirect to login controller that takes care of redirecting to the login path when a user is not authorized, and I have the login display that takes care of showing the user identity. So I'm going to run the app. Sorry, I started debugging and it doesn't like it when I do debugging, because I have all the settings to debug into the framework. Okay, so we're here, we can log in. Just checking the login state. As you can see here, we are going to the authorized endpoint. I'm logged in and I'm authenticated. I can go to the user. I can see my access token, the claims in the token, the claims in the user. I can log out. And if I hit an authorized endpoint like fetch data, it automatically detects that I don't have the right scope and sends me back to the login endpoint where I can log in again and sends me back to where I was and displays the data. So that's full auth support in the same way that we have in the using Identity Server, in the same way that we have for the React and SPA templates. And I built all of this in a day, I think, using JS Interop and leveraging all the code from third-party libraries that was already there. So most of the implementation is here in this API authentication service that simply has a bunch of method calls to JS Interop, and you can see that I can be very smart or very complex. That is not that I don't have. I can write generics. I can use all those type of things. Then I have a method here that gets the claims principal, and all of this is piped through this authentication service. And if we see the authentication service, we're gonna compare it to the React version, which is this authorized service here. We can see that besides a few things here, like the imports and all the stuff, they are pretty much the same. You can see this is authenticated, get user, and they are literally the same code. The main things this authentication service have are actually at the bottom of the file, where I simply created a class to hold on to all my state and to initialize it once. And what we do in the app, which is the pattern that I like to follow, is the main class has an equivalent JavaScript side of things. It has a set of static methods that makes it easy to call. And we simply have an init method that initializes a singleton, and then helper methods that make it trivial to call the JavaScript side of things. And then I piped a bunch of like random helpers here to do small things. So for example, I didn't want to write my own query parsing logic, and there is this URL search params class in JavaScript that you can use. So 3 lines of code, and I didn't have to bring in a .NET library or write my own parsing code, essentially. So that's the end of my demos. I'm gonna go back to the slides. So the main things that I want you to take away from here is that it's very easy to convert third-party solutions to Blazor by leveraging JS Interop. We can call browser APIs directly or leverage built-in behavior. That's another good use case if we don't want to use a library, for example, like I did just now. And we can encapsulate all the JS Interop code into a small portion of our app. It's not something that creeps up through all our components and elements. We can isolate it into a very small portion, or even better, use a library of one of the many libraries that are out there. So with that, I want to say thank you and share with you a few final thoughts. We've seen how to use JS Interop to leverage browser APIs and third-party libraries. We've seen how to handle site when doing JS Interop. We've seen how to support pre-rendering and other scenarios by using JS Interop inside and after render. We've seen how to parse large amounts of data. And the most important thing to take away is that there's people that has already written these libraries for you so that you don't have to. So with that, I hand it back to you.
Hey, Javier, thank you so much for the great presentations. We do have some questions on Twitter. Unfortunately, we are out of time for you to answer them live right now. So if you can hop on Twitter and look at the .NET hashtag .NETConf and look at those questions, that'd be great. Thank you so much again for taking the time to speak with us. We're going to go into a quick commercial break so we can get Eagle Hansen, who is going to be talking about testing all the way from Iceland. So we'll be right back with .NETConf Focus on Blazor.